The Airbus 330 is one of the most sophisticated airplanes flying in the sky. This aircraft from Airbus has flyby controls. That means it uses electrical signals and computers compared to conventional wires, which are used to move the control surfaces without much physical effort to fly the airplane. These sophisticated computers assist in higher degree of automation, which also provides extra layer of safety and protection. Thus, it keeps the airplane in a safe flight envelope. The idea of such automation and computers reduces pilot workload quite significantly and keeps them more aware to address the current dynamic and busier aviation environment. Hey everyone, today I'm going to tell you about a Cathay Pacific Flight 780, which departed from Surabaya Airport in Indonesia to Hong Kong International Airport. But who knew that a normal Cathay Pacific flight operating on Airbus 330 would encounter such a dramatic fate while returning back to Hong Kong? The crew of Cathay Pacific 780 had carried out a sector from Hong Kong to Surabaya on previous day with Airbus 330 series without any event. The flight crew had to do an overnight stay, or in aviation terms a layover, in Surabaya. The crew, which included one commander, one co-pilot and 11 cabin crew, reported for duty at 0020 hours. During the pre-flight, the flight crew had to do pre-flight procedures, which includes various checks like checking of the aircraft technical status, weather of departure, en route airports, destination, as well as alternate airport. They also had to check if there are any significant notices to aircrew about other aviation facilities on the route. Everything looked good that day, and there was no airplane system-related defect reported in the aircraft technical logbook for the aircraft. The actual weather and the forecast weather along the flight plan route and other requirements for the flight was accepted by the flight crew. The aircraft was parked at stand number 8 on the tarmac. Pilot had to do an outside inspection of the airplane before every flight. The commander completed the walk-around inspection and didn't find any abnormality. He noticed that the fuel dispenser operator was completing a water check of the fuel sample. Before every flight, if an aircraft is refueled, a water contamination check is carried out to check the presence of water in the fuel. The captain observed that the fuel sample in the beaker was clear, bright, and the water check was clean and satisfactory as per the standards. The dispenser operator considered that the vibration was due to air trapped inside the hydrant piping, which had been disturbed in an extension work recently. The dispenser operator stopped the refueling at each occasion to stop the vibration and resumed refueling afterwards. At the end of refueling, a visual water check of the dispenser fuel sample was performed, together with the Cathay Pacific ground engineer, and it was reported that the result was clear with no trace of water, so things proceeded as normal. The aircraft uplifted 24,400 kilograms of fuel at the stand. The departure fuel quantity was 33,400, which was planned by the dispatch and accepted by the flight commander. Zero fuel weight of the aircraft was 165,372 kilograms, and the actual takeoff weight was around 198,700. The total number of passengers on board the flight was 309, which meant the flight was pretty much full. On every flight, the flight crew decides who will be the pilot flying and who will be the pilot monitoring. The idea behind this role play is to carry out various responsibilities during the flight, which is also defined by zones of responsibility in a flight deck. Pilot's flying main task is to maintain the airplane control and navigate as per flight plan, as well as ATC instructions. While the pilot monitoring assists the pilot flying by monitoring his actions as per instructions, he also talks to ATC and carry out other actions as required by the pilot flying. So for this leg, the co-pilot was the pilot flying and the commander of the flight was pilot monitoring. The cabin crew conducted the safety demonstration to the passengers, which included emergency evacuation procedure in accordance with the company requirements. These security demos was carried out with the assistance of in-flight video and safety cards. The aircraft was pushed back from stand 0111 hours and after starting both engines, they were given taxi instructions to taxi to runway 28. At time 012 hours, the flight took off from runway 28. The departure was flown in visual meteorological conditions and was away from any significant weather. On passing 1144 feet above mean sea level, autopilot 2 was selected and engaged. According to the flight crew, Cathay Pacific 780 did not encounter any significant weather en route, which was also confirmed from the satellite imageries for the period. The flight was proceeding as per routine, but during the climb, the flight crew noticed some abnormal fluctuations on one of the engine parameters. This was engine pressure ratio, or EPR, was fluctuating on engine number 2 with the range of approximately plus minus 0.015 around the EPR target. Number 1 engine also had abnormal EPR fluctuations, but within a narrow range. Pilots don't see such fluctuations on regular basis with engine parameters. Normally, engines have various parameters that indicates engine's performance, and those needs to be monitored by the flight crew. They consist of number of rotations per minute of the turbines calculated in N1 and N2 percentage, the temperature of engine exhaust, in addition to engine oil, its temperature and pressure. EPR, which is engine pressure ratio, is generally the pressure difference between the output pressure of air produced by the engine to input pressure of the air. It's mostly on engines which are used by Airbus airplanes and various other engine manufacturers. At time 0158, the aircraft was still inside the Indonesian Ujung Pandang flight information region and just leveled off to flight level 390. At around the same time, the Electronic Centralized Aircraft Monitoring, or ECAM message, engine to system fault, was annunciated, which indicated some problem with the engine number 2. So for Airbus airplanes, ECAM is Electronic Centralized Aircraft Monitoring, which monitors main aircraft systems such as engine, hydraulic, electrical, flight controls, along with the presentation of their schematics. It also generates indication and faults in the system to flight crew. For these failures, it presents actions to the flight crew in the form of checklists. It's quite a sophisticated system to assist pilot in understanding the problem and the operation of various aircraft systems and its computers. When the flight crew executes these actions of the checklist, it either isolates a part of the faulty system or shuts down the system entirely without affecting the safety of the operations. After the first ECAM message on Cathay Pacific 780, another ECAM message, engine to slow response, appeared. This message only required crew awareness and did not require any pilot actions. They only had to monitor engine parameters this time. So in an airline flying, when a flight crew generally encounter an in-flight problem or a failure related to the airplane system, they try to contact their operations control center or maintenance control center. They use satellite communication or SATCOM as a part of their problem-solving procedure to seek additional information and better decision-making. Using SATCOM or satellite communication, crew members can talk to their operations control center located at their main base station. At 0200 hours, the flight crew contacted Cathay Pacific Operations Control Center, which is called Integrated Operations Control Center, or IOC. The maintenance engineer at IOC asked the flight crew to check the responses of the engine's two thrust lever movements. The flight crew advised that the EPR was fluctuating around an EPR target. Both the flight crew and maintenance engineer reviewed the Flight Crew Operations Manual, Volume 3. The option of setting the engine control to N1 or RPM mode was discussed between the flight crew and the maintenance engineer. Since the engine control was normal without any other abnormal engine indications, and also the previous ECAM messages have disappeared at that time, the maintenance advised that the flight crew to maintain engine control at EPR mode and indicated that IOC would continue to monitor the flight. The flight crew agreed that all engine parameters were considered normal other than the EPR fluctuations, so they decided to continue the flight to Hong Kong, considering that the problem is not that severe. At 0315 hours, Cathay Pacific 780 started to descend to flight level 380. At that time, they entered Malaysian Kota Kinabalu airspace. At 0316 hours, ECAM message engine to control system fault reappeared when the aircraft was leveling off at flight level 380. But at this time, it came with added ECAM information, which is avoid rapid thrust changes, in addition to engine to slow response. As one can understand that the problem with the engine began to add some more. There was definitely something not working properly with the engine number 2. So the engine NTIs for both engines was selected on by the flight crew between time 0317 hours to 0327 hours. The purpose of checking the engine NTIs was to check their effect on EPR fluctuations, but apparently it had no effect to those fluctuations. The flight crew called the IOC again via SATCOM for further discussion. Another maintenance engineer responded to the call and confirmed that he was aware of the earlier situation as they've been monitoring the engine parameters during the flight and observed increase in EPR fluctuation plus minus 0.1 for number 2 engine and plus minus 0.3 for number 1 engine. The flight crew queried whether it was safe to continue the flight because additional failures on engine number 2 have appeared. Maintenance engineer number 2 confirmed that there was no maintenance carried out overnight in Surabaya before the flight. Maintenance engineer 2 considered that the number 1 engine was functioning properly and the number 1 engine EPR instability might be caused by the FedEx using number 1 engine to compensate for the EPR fluctuation of number 2 engine. FedEx is full authority digital engine control system, which is an engine monitoring computer. The engineer further advised the flight crew that they had seen this kind of fluctuation before and the ECAM information avoid rapid thrust changes was related to P30, which was related to variable stator vane or VSV system. Variable stator vane is one of the fan blade assembly in the engine. The engineer suggested the flight crew to monitor the parameters with care to avoid any accidents and additionally move the thrust levers with care. He also reminded the flight crew to follow FCOM procedures if any accidents occurred. The engineer said that the fuel monitoring in number 2 engine would be replaced upon arriving at Hong Kong. So after this conversation, the flight crew accepted the engineer's explanation and continued the flight to Hong Kong. So at around 0455 hours before entering the Hong Kong FIR, the flight crew obtained the arrival weather via Automatic Terminal Information Service or ATIS. The runway in use at Hong Kong was 07 left. Wind was from 160 degrees at 9 knot with wind direction varying between 100 degrees and 230 degrees. Visibility was 10 kilometers, few clouds at 600 feet scattered at 1800 feet. Temperature in Hong Kong was 29 degrees that day. QNH was 1013. But significant wind shear was forecasted on both runways 01 left and 07 right. Wind shear is a sudden change in the direction of the wind or speed, which is a major hazard to the aircraft and is quite common at Hong Kong airport. Now the flight crew began to do their regular approach preparation. At 0458 hours before entering the Hong Kong FIR, Cathay Pacific 780 contact radar or 128.75. They were cleared for a standard arrival route Sabano to Alpha for runway 07 left. The flight crew carried out arrival and approach briefing in accordance with the company procedures. They also completed their descent checklist, selected config full, which was maintained as a default setting in the MCDU, which is multi-purpose control display unit. Instrument landing system or ILS frequency for runway 07 left was automatically tuned. Auto brake system low was set. Cathay Pacific 780 entered Hong Kong FIR via waypoint Sabano at 0504 hours, and around the same time, Hong Kong radar had radar contact with them. The commander made a normal public address to passengers. So by now, the airplane and the flight crew were ready for a regular descent. At 0519 hours during descent, they were cleared to descend to flight level 230. And as they were descending, the ECAM message, Engine 1 control system fault and Engines 2 stall were enunciated within a short period of time. So engine number 2 had encountered a new and a bigger problem, and also engine number 1 developed a previous but same problem as engine number 1. Now the situation is getting more dramatic having some problem on both engines will easily raise alarm bells in the minds of the flight crew. This is very unusual that both engines are having problem at the same time. The commander also heard a light pop-like sound and some ozone and burning smell was detected, which was shortly before ECAM message engine to stall appeared in the ECAM. Engine stall means that the smooth flow of air going inside engines has been disrupted by some kind of failure. If the correct actions are not taken by the flight crew, within a short time the engine can get further damage and eventually fail. The flight crew understood how the situation is becoming more complex and dangerous. At that time, Cathay Pacific 780 was about 110 nautical miles southeast of Hong Kong and was descending through flight level 300 with a speed of 295 knots and a heading of 330 degrees. The vertical mode open descent was selected. The flight crew completed the necessary ECAM actions and set the engine number 2 thrust lever accordingly to idle position. ECAM information, engine 1 slow response and avoid rapid thrust changes were also enunciated again. Now the flight crew began to do their train procedures according to the engine fail scenario. Number 1 thrust lever was advanced to max continuous thrust or MCT position as per the single engine operation strategy as stated in the Quick Reference Handbook or QRH. However, number 1 engine only temporarily increased to about 57% of N1 and then dropped back to about 37% of N1 at time 0521 hours, which is close to being engine running at idle power. So at time 521 hours, the flight crew declared pan, which is an urgency signal on Hong Kong radar frequency 126.3 and advised that the engine number 2 was operating at idle thrust. These are the standard phrases used by flight crew to inform ATC that they are having some problem which could affect the safety of the flight and need urgent assistance from ATC in their airspace, and also inform safety and rescue services to stay on alert. The flight crew considered to brief for one engine inoperative approach and misapproach procedures. Config 3 setting was reselected in the MCDU. The flight crew also requested to shorten the track miles for a priority landing. Hong Kong radar then cleared Cathay Pacific 780 to proceed directly to waypoint lines. Air traffic control also alerted airport fire contingent service accordingly by declaring local standby. With this abnormal situation, the commander instructed the cabin crew to prepare the cabin for a landing via PA channel. He also established the communication with in-flight safety manager and advised her that there was a problem on engine number 2 and a priority landing would be accorded by the ATC. The ISM was asked to prepare the cabin for landing and to report to him if there are any abnormal indications in the cabin or on engine number 2. At 0526 hours, the commander took control of the aircraft as PF in accordance with the Cathay Pacific standard operating procedures for one engine inoperative and the co-pilot became the pilot monitoring. At 0530 hours, the aircraft was approximately 45 nautical miles southeast of Hong Kong and was about to level off at 8,000 feet. By this time, the crew pretty much mitigated this single engine scenario as per their procedures and was ready to execute the approach. Then another unfortunate event occurred that compromised the safety of the flight to a critical level. Now ECAM message engine 1 stall was enunciated. It was the same fault in the same sequence what failed engine number 2. That's a double trouble. Now the both engines are giving engine stall indication, which is equivalent to both engine failure scenario if the engines don't recover. It's one of those situations which pilots don't want to witness ever in their flying career. This basically cripples the airplane, which can only now glide since the engines can't produce thrust, and depending upon the aircraft altitude, speed and energy, it can only glide to a certain distance. The speed at that moment was 295 knots, which is also indication of kinetic energy which can assist in gliding to the runway. ECAM actions were carried out by the flight crew and number 1 thrust lever was put to idle position accordingly. Auto thrust was disengaged and both the engine master switches remained at on position. With both thrust levers at idle position, the commander then tested the controllability of the engines by moving the thrust levers one at a time. There were no thrust changes corresponding to the engine lever movements initially. At 0532 hours, the ECAM message engine 1 stall also enunciated again. And at this time, the crew declared Mayday, 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 which is the distress signals on Hong Kong approach frequency 119.1 and advise Hong Kong approach of double engine stall situation. Now declaring Mayday is telling ATC that the flight is in life-threatening situation and they had to land immediately and they'll need all the assistance from the air traffic control. At that time, the aircraft was still in instrument meteorological condition and the speed was about 233 knots and reducing. The heading was approximately 320 degrees. At around the same time, the commander decided to take matter in his own hands and try to fly the crippled Airbus A330 manually. This is where the last line of defense, which our flight crew, comes into further action. He disconnected the autopilot and flight directors and flew the aircraft manually using the flight path vector. This is quite an unusual and different thinking by the captain, since they are no more in normal situation and believe that he could fly an airplane better than the autopilot with asymmetric thrust on both engines. The most interesting part is they couldn't understand why is this happening to both engines at the same time. The altitude increased from 6,700 to approximately 7,100 and the aircraft started to descend again when the speed decreased to 202 knots, which was the green dot speed. The green dot speed is one of the engine out operating speed in clean configuration, as well as the best gliding speed. At 0534 hours, the flight crew selected the auxiliary power unit to on. Engine start selector was selected to ignition shortly afterwards. When the aircraft was on base leg during the approach, the flight crew reported that they were flying in VMC or visual met condition and they could visually see the airport terrain and the runway. The crew moved the thrust levers to check the engine control, but there was no direct response from the engines. But some fortune favored the flight crew at this time. The number one engine speed eventually increased to about 74% N1, with number one engine thrust lever in climb return position. The number two engine remained at sub-idle about 17% N1, with the thrust lever number 2 at idle position. At 0536 hours, the co-pilot made an announcement, "Cabin crew, please be seated for landing," followed by another PA, "Cabin crew, 2 stations." This call to cabin crew is used to tell them that they need to be ready for emergency landing as well as a probable emergency evacuation after landing and stopping of the aircraft. Shortly afterwards, the cabin crew advised the flight crew that the cabin was ready for landing. At 0537 hours, the ATC made both runways 07 left and 07 right available for Cathay Pacific 780. During the descent and approach, there were a number of other ECAM warning messages announced in the cockpit, which were not relevant to the engine control problem. The flight crew carried out all engine flame out fuel remaining checklist in the QRH and its respective steps to recover the engine number 2 with an attempt to clear the thrust control fault of that engine. As per the checklist, the ram air turbine was deployed manually, APU bleed was selected on, and the engine number 2 master switch was selected off, then on at time 0538 hours. However, engine number 2 remained at sub-idle speed of 17% N1. The amount of workload on both captain and co-pilot is massive now. They have to do multiple checklists along with flying a crippled airplane to landing. At 0538 hours, flap 1 was selected. At 0539 hours, the Cathay Pacific 780 was around 5,500 feet, the heading of 329 degrees and a speed of 220 knots with a distance of 9 nautical miles from Hong Kong. The commander tried to decrease the speed by retarding the thrust lever number 1. However, there was no corresponding decrease in number 1 engine speed. Eventually, the number 1 thrust lever was at idle position and the number 1 engine speed remained at 74% N1. Now they are encountering a grave situation in which one engine has failed while the other engine, in this case number 1 engine, is producing excessive amount of thrust, which can be dangerous for a regular approach. This another added situation with the thrust of number 1 engine stuck at 74% is quite higher to descend towards the runway for landing. They'll be approaching the runway being high and fast during the final approach segment, unlike a nominal 3-degree flight path and a proper approach speed. At 0539 hours, the commander made another PA, advising the passengers of having small problems with the engines with small vibrations and requesting them to remain seated and follow the directions from the cabin crew. At 0540 hours, Hong Kong approach cleared Cathay Pacific 780 for a visual approach for runway 07 left. The flight crew deployed the speed brakes when the aircraft was around 5,200 feet, descending with a speed of 234 knots. The aircraft was around 8 nautical miles from the airport. The flight crew selected the landing gear down shortly afterwards. Okay, let me explain a nominal 3-degree glide path for an aircraft. In a normal scenario, on a normal approach, the aircraft altitude in feet should be approximately 3 times the distance to land in nautical miles. So if an aircraft is 8 nautical miles from the runway, it should be approximately 2,400 feet and close to fully configured for landing with the correct approach speed between 140 to 150 knots. But Cathay Pacific 780 are more than double the height and 80% faster in comparison to a profile what a normal airplane on approach follows. But the situation is not normal for this Airbus A330 in their scenario. The commander aimed to fly the aircraft at a speed as close as possible to the minimum selectable speed or VLS, which was 158 knots at that time, to control the airplane energy for landing and stopping within the landing distance. The aircraft went through the extended runway centerline and recaptured the centerline from the north in order to manage the altitude and airspeed. Then the landing checklist was actioned by the flight crew. At around 0541 hours, with the maximum allowable speed or Vmax at 250 knots and actual speed at 244 knots, an overspeed warning was generated by onboard system because the number 1 engine is stuck at more than required thrust setting. They were using the speed brakes to reduce the airspeed and increase the rate of descent. Short while later, Hong Kong approach cleared Cathay Pacific 780 to land on runway 07 left and advised that the current winds was 150 degrees and 13 knots. The flight crew stored the speed brakes when the aircraft was around 900 feet and armed the ground spoilers at around 800 feet. At 0542, Cathay Pacific 780 was still at flap config 1 with a speed of 227 knots and a vertical speed of around 1200 feet per minute. They were at an altitude of 700 feet and about 2 nautical miles from touchdown. To get the attention, the warning too low terrain was generated by the Enhanced Ground Proximity Warning System or EGPWS because they were not in a proper landing configuration at that time. So along with the problems with the engines, now the situation where they are high, fast and not safely configured could cause the Airbus A330 to land far beyond the landing point and go out of the runway. Flap config 2 was selected at around 1 nautical mile to touchdown with a speed of 234 knots and at an altitude of 500 feet. The moment config 2 was selected, a flashing flap relief message was displayed on engine warning display as the trailing edge flap was extended to 8 degrees instead of commanded 14 degrees position. And with a Vmax of 205 knots, another overspeed warning was generated shortly after flap 2 selection. So this time, too low terrain warning changed to pull-up warning briefly at around 200 feet and back to too low terrain within a very short time frame. The EGPWS warning stopped just at 24 feet above the ground. There were all sorts of bells, warnings and rings as the airplane gets close to just 24 feet above the runway. During the final approach, number 1 engine speed decreased to about 70% at touchdown with number 1 thrust lever at idle position. The number 2 engine speed remained at about 17% N1 throughout the final approach and landing. So Cathay Pacific 780 touched down on runway 07 left at time 0543 hours at a position between a beam taxiways Alpha 4 and Alpha 5 and with a distance of around 680 meters from the beginning of the runway threshold at a ground speed of around 230 knots, which was way high for touchdown. They basically touched down more than double the distance for a normal landing. The landing weight at that time was approximately 173,600 kilograms. Immediately after the both main landing gears touched down on the runway, the right main gear bounced and the aircraft became airborne again briefly. The obvious reason was the high rate of descent and the energy with which the aircraft contacted the runway. The aircraft then rode left 7 degrees and pitched down to minus 2.5 degrees at the second touchdown, during which the lower cowling of number 1 engine contacted the runway surface. Spoilers deployed automatically and both the thrust reversers were selected by the commander. But only number 1 engine thrust reversers was deployed successfully. ECAM message engine to reverser fault was enunciated because of the fault. The commander applied maximum manual braking to stop the airplane, as required by the company procedure for the purpose of drawing the PF's attention to the status of the deceleration devices. The co-pilot called out no spoilers, no reversers, and no deceleration during the landing roll. The airplane came to complete stop on the runway at a position past taxiway Alpha 10 with a nose wheel at about 309 meters from the end of the runway 07 left. The total distance for stopping the aircraft from initial touchdown was approximately 2,630 meters, which was very impressive considering how high and fast the aircraft was approaching for the landing runway. After the parking brake was set, the commander made a PA to request the passengers to remain seated. Number 1 engine was still running between 76 to 79% of N1 with number 1 thrust lever at idle. The crew shut down both engines by selecting the number 1 and number 2 engine master switches to off. The brake temperatures were monitored and discussed between the commander and the co-pilot. The brake temperatures reached the top of the scale at 995 degrees in the cockpit display. So the problem is still not over after landing a crippled Airbus A330 on the runway and stopping within the landing distance. The commander made another PA advising the passengers that the flight crew was evaluating the situation and the passengers were requested once again to remain seated and follow the cabin crew's instruction. At 0545 hours, the flight crew contacted Tower North on frequency 118.2 and asked for any indication of a wheel fire. The tower controller advised that she had not seen any fire yet and advised Cathay Pacific 780 to contact on-scene officer in charge of the AFC call sign rescue leader on 121.9. So before making the communication with the rescue leader, the commander called for the emergency evacuation checklist. Checklist actions before the item evacuation call were completed. Accordingly, an instruction cabin crew to stations was broadcasted through the PA system and the fire push buttons for both engines were pushed. After further confirmation on the rescue leader frequency with the tower controller, the commander eventually established communication with the rescue leader on 121.9 at time 0548 hours. The rescue leader confirmed that the brakes on left and right gears were hot and he could see smoke and small fire. The rescue leader further advised the flight crew that the water was applied to cool down the hot brakes. Now this can be a debatable action, but the commander took action what he felt right at the time in terms of the safety of the flight and the passengers. The commander then ordered an emergency evacuation. So for emergency evacuation, they shut down the APU using the APU fire push button as per the emergency evacuation checklist. Inside the cabin, when the aircraft came to complete stop on the runway, the cabin crew repeated and shouted out commander's instruction and instructed the passengers to remain seated. Most of the passengers followed that instruction except a few who intended to rise from the seat and looked outside the windows. Later, when the commander ordered evacuate, the cabin crew responded to the command immediately and initiated the evacuation. All the 8 emergency exits and doors were used after the cabin crew had confirmed the absence of fire or smoke outside the exits. Exit doors L1, R1 and R4 were each attended by 2 cabin crew members, and the remaining 5 exit doors were each attended by 1 cabin crew member. Some passengers, as always, took their cabin bags along and did not follow the cabin crew instructions to leave their bags behind before jumping onto the slides. The whole evacuation was completed in 2 minutes and 15 seconds, and the commander, the co-pilot, and the ISM walked through the cabin to make sure there was no one left inside before they leave the aircraft. There were a total of 322 persons on board the aircraft, including 13 crew members and 309 passengers. All injuries occurred during the evacuation when the passengers were coming down the slides. There were 56 passengers who sustained minor injuries. So the question arises, what really happened? Why Cathay Pacific 780 ended up in such a situation? The analysis of the engine on Cathay Pacific Flight 780 revealed that the fuel system was contaminated, specifically with superabsorbent polymer or SAP particles. These particles were introduced into the fuel system when the aircraft was fueled at Surabaya. The Hong Kong Civil Aviation Department's Accident and Investigation Division concluded that this contamination caused the loss of thrust control on both engines during the approach to Hong Kong. The SAP particles originated from the filter monitors installed in the fueling dispenser at Juanda Airport. These particles caused the main metering valves of the fuel metering unit to seize, leading to the loss of thrust control. Additionally, other engine components were found to be contaminated with the similar particles, and the variable stator vane controller of engine number 2 was seized that time. The investigation further revealed that the fuel supply pipeline system used to refuel aircraft at Juanda International Airport had been recently extended during the construction of new aircraft parking bays. However, not all procedures were followed when the system was brought back into service and the salt water had accidentally entered the fuel supply. The presence of salt water compromised the filter monitors in the pipeline system, releasing SAP particles into the fuel. And the dispenser took that contaminated fuel and tried to refuel Cathay Pacific 780, and that was also the reason for the vibration of the dispenser and fueling pipe during the refueling process, which was considered incorrectly as a trapped air by the operator. So in summary, the contamination of aviation fuel caused the failure of both engines of Cathay Pacific 780 on approach. The civil aviation authorities of both countries took measures and precautions to avoid such kind of disaster in future. So that brings us to the close of this video. I hope you enjoyed and gained some more aviation knowledge. Thanks for watching. See you in the next one.